Page 107, we're doing question number 1. Complete the chart by stating the directions of the vectors A, B, and C. Okay, let's take a look at A. This 40 degrees, right here, it is what compared to north? East of north. Okay, so 40 degrees east of north. Okay, is there another way you could have talked about that vector? That same vector, could you have went this way? 50 degrees what? North of east 50. They are equivalent. Okay, when you're doing this, you might look over at your neighbor, they might have something different, but it might be the same, so just think about it for a second. I'm not too worried about bearings, but bearings start at 0 and rotate clockwise. So the bearing for A is 40. Okay, and now for these cardinal references, they also want you to just rewrite it by a different way. So I'm going to cross that out and I'm going to put RCS here. So for A, the RCS is 50. Starting at 0 on east, it's just 50. Okay, let's go to B. I'll erase this stuff so it's legible. Okay, let's take a look at B. Where's B? Down in the quadrant 4? Okay, so for a bearing, starting at 0 at the top, you got to go down here to 90. Plus 70 is 160. Now the reference would be 70 degrees south of east. And sometimes I get confused with my east and west, but I like to think about it like over here's Vancouver and over here's Toronto. I don't know. Sometimes my east and west gets mixed up. Anyways, the RCS. So for this 70-degree angle down here, for RCS, we start on the eastern horizon, 0, and we rotate counterclockwise. So I'll use purple. Starting here, that's 90, 180, 270, and then we get to here, which is, well, if that's 70, this is 20, right? So 270 plus 20 is 290. So 290 there. Any questions on the RCS? Start at the east and go around till you find your angle. Go counterclockwise for RCS. Counterclockwise. And that's what they do in math, and you'll see that, especially the 20-1s in here, you're going to see it Wednesday when we start trig. Yes. Okay, let's find C. Let's erase all this junk. Okay, C. Okay. The bearing. The bearing, we could use what Precious just said, so 360 minus 60 would be 300 for the bearing. For C? No, you start at 0, right? Up in the north, and you rotate clockwise. 90, 180, 270 plus 60, yeah, 330. Sorry. And no, every teacher needs a check, that's good. Okay, now what? For cardinal reference, this 60 would be north of Vancouver. Right, north of west. Where's my pen? North? Why is it doing that? North of west, and the number is 60. Okay, and for the RCS, for 60 there, start at 0, and you go, I'll use purple, go all the way to there, and then stop. So it's 180 minus 60, which is, help me, 120, thank you. Okay. Let's just live in here for now. Cardinal references. Just be aware of these. Be aware of bearings. Be aware of RCS. But let's live here. Can we all agree to that? Okay. Let's live in the cardinal references. That's what we'll stick with as a class. Okay? And I've taught you the other ones so you know about them. Okay, let's move on. Don't worry too much about 2, even 3. Like, they want you to use a protractor. Like, I think let's just... I like 5 and 6 though, because what 5 and 6 gives you is an example where, okay, this person is going on these journeys, these like independent trips. Okay, so you go, let's go like, you know, position 1 to position 2 to position 3 to position 4 and then to position 5. They do all this stuff, right? But what actually happened? You're actually what? Displaced. That's your displacement. And what do they call this? It starts with R. No. Resultant. Okay, this is what actually has happened. You did all this other stuff. These are a bunch of distances being covered in certain amounts of time, but the actual displacement from the reference point A to B. Okay? And how would we find what this is? What is this x going to be? This x in the bottom. What is that? How are we going to find that x? Well, it's the x from the trip from 2 to 3, and it's the x from the trip from 4 to 5. Those two components are going to combine for the total displacement in x. And what about in y? How much displacement is there actually going to happen in y? Good. Why did you minus, Hamza? You know. It has to do with direction. Why do we minus? This is north, and then you travel south. Are they in opposite directions? So when you add them, one is positive, the other is negative. But the yellow ones were in the same direction, right? So we just added them. For the red ones, we have to subtract. And then that's when you'll get this displacement in the y. Okay, and then how to find r? Square root of x squared plus y squared. Just memorize that. That's so fast. You don't have to show any work. Just show this. R equals square root x squared plus y squared. Memorize this. And how to find the angle? No, always tangent theta inverse y over x. Okay? Please memorize those. Those two. That's all you got to do. All right. You guys can do 6 for our homework if you haven't done it already. Let's go to number 4.2 section.
I never memorized it this way, but I memorized it as c squared equals
It's the same.
a squared plus.
Yep. And how to get rid of this too? Square root this.
I was square rooting it back.
And then square root this too. Yep, square root this now. If you square root this side, square root this side. Good. And this is x, this is y, and this is r.
Yeah.
Yep. And you do it all in one step, my friend. You go like this. Bracket. And then x squared plus y squared. So 5 squared plus whatever the numbers are. Done. One step. Question?
Does it really matter if it's like, if you got it backwards, like east of south, side of east?
No, doesn't matter. Same spot. Okay, let's take a look at number 1. This is trig review. Trig review. 1A. Sorry, my... Okay, for A, let's look at A. Are you solving for a long side? Okay, so we're going to add up and square. 4 squared plus 5 squared, and then square root that thing. Okay? That will be x. Let's take a look at B. In B, you're solving for the short side or the long side? Short side. So we're going to have a subtraction. Shit! Scare me! Oh, that frightened me. Let's go. Out there. To the left. Let's continue on. Let's take a look at, where are we? Letter B here. Okay, so it's a short side Pythagoras, so instead of adding, we have to subtract. You should know this from your studies of math in junior high. So you put the big number first, obviously, 8 squared minus 6 squared, and you'll get x like that. So those are the two Pythagorean theorems, solving for the long side, solving for the short side. Just memorize those and you'll be fine. Because you have so much bigger things to worry about in physics that you can't be worrying about like these simple trig calculations. Okay, let's take a look at C. X is the height, right? The vertical component. I don't like that they use x here. I wish they used a y, because it is like a y component if you think about it. So how can we solve for that vertical here? How do we solve for this? Sine, right? And then you'd have to multiply by the... Yeah, it's 5 sine 35, exactly. And that will give you that vertical component, x. Now when we're looking at D there, this one's going to be opposite over adjacent, so straight tangent. And I like that it's y over x, so that's perfect. Let's look at E. E involves the adjacent and the hypotenuse, so inverse cosine. Good, inverse cosine. And that'll be 5 over 7. And then for F, okay, now we're up here, so straight across, that's opposite, inverse sine. Yeah, opposite over hypotenuse, inverse sine. Okay, so that's pretty straightforward. Let's go to number 2. The igloo-shaped church here, historical building, blah, blah, blah. Sammy follows the path shown below. Determine Sammy's displacement relative to starting point. Okay, so this person walks what? 40 meters north. And then what? 60 meters east. So the actual displacement from the start point is this result. So 40 squared plus 60 squared all in the... Okay, and it just tells us right there, so 72.
Well, good afternoon, staff and students. Thank you very much for, that was our third fire drill process. That should be our last fire drill process here
Nice.
this fall. But anyways, well done. We evacuated the building in about 2 minutes and 25 seconds, which is really good. Again, in the event of a real emergency, we remind students and staff that there'll be no talking. You evacuate from the building, and then staff, you'd be expected to take attendance of your students at that time outside, waiting for further instructions. But well done. Thank you very much, and we hope you enjoy the rest of this afternoon.
Okay, inverse tangent for the angle, and the y over x will be, in this case, a little bit different because it's tilted, right? So if we go theta here, it's going to be the opposite over the adjacent. It's actually the x over the y. So you got to be careful with my notes that you're smarter than that. You understand that tangent is always the opposite over the adjacent. So for this one here, you're going to go 60 over 40. And you should get... Oh, just got my calculator here. Okay, and also some people, like, you're not in degree mode in your calculator and you're getting really weird answers. So make sure you're in degree mode. So I get inverse tangent 60 over 40. I got 56 degrees. And for degrees, usually you don't need to go into the decimals. But it looks like 2 sig digs probably for this question. And then what is this angle? This is east of north. Okay, and then just showing you, again, just reminding you, because sometimes we forget in physics that vectors have both magnitude and direction. So the actual displacement, if you want to like write this out like really neat, would have this. And then, of course, the way that you communicate the angle, that's optional. There's 3 or 4 methods that you can try. But we're going to stick with these references like this. All right, so we cool on that? All right. So 3, 4, and 5. I'll leave 3 for you because it's identical. I'll leave 4 for you because it's identical. Let's try 5. Okay, let's try 5 together. A bus travels 100 kilometers due north and then turns and travels 120 kilometers due west. Did I go the wrong way? I always do that. You know why? I don't know why. Just like, it's like east-west dyslexia. Okay, 100 north, and then 120 west. Okay, so actual displacement will be that right there. Okay, so just a word on what we're doing. The diagram, what do we call it in red here? Read it out, everybody. Everybody, loud and proud.
Tip to tail.
Thank you. Everyone again. This side. Yeah, tail to tip, tip to tail, however you want to say it. But we line up our vectors like this. Okay, tip to tail, or head to toe, whatever you want to say it. You have to line up your vectors like that. That's going to be, this is like, how would we say this? Perpendicular vector addition. Okay? And it's at right angles, so if it's at right angles, we can always go with our primary trig. Okay, Hamza, you got something on the ground there. Okay, so how to calculate this result? Well, it's going to be 100 squared plus 120 squared. Okay? And then we have to square root that, obviously. So 156, it says right there, thank you. Okay, and now the direction, if we're theta's up in the corner there, no. Where's theta? Down in the bottom?
Yeah.
Well, how do you guys know? Does it matter? It should be from like where you started, right? I agree. This is a reference point. So where do we start? If you were to like overlay, let me see if I can do this with a tool. If I was to like overlay a grid from the reference point, okay, what's this angle in here? It is what? Thank you, west of north. Good. So, and it tells us right there in our answer. So when we go to do our second function tangent, we have opposite on top of adjacent. So in this case, 120 over 100. Okay? And are we getting this? Okay? And why is there 3 digits? 3 sig digs, right? 120, 100, 2.00. 3 sig digs everywhere. Okay? A lot of people still forgetting about that. Lots of little details in physics. 3 sig digs. Okay, so let's try to figure out this answer. A is the displacement, which just combines the magnitude of the hypotenuse and the direction of the hypotenuse. And you can see the answer right there in the square bracket. Now let's take a moment to talk about B and C. How to do B, average speed. Good. Elgin said it pretty straightforward. V average is equal to D over T. And the D stands for distance here, right? Total distance covered, 220. That's the actual journey. That's the actual distance covered by the bus, right? So 220. It's 100 up, it's 120 over. That's what the bus actually does. And the total time, do we have to find those? They give it to us. 2 hours. Thank you. 2 hours right here. And then we have, this unit is kilometer, this unit is hour, so it's going to work out nicely, 110, right? Okay, now for C, they want average velocity. So instead of using distance, we have to use displacement. And then if you're using displacement, you're going to use that answer from A. Okay? And don't forget about the direction for that velocity. Right? Because it uses displacement, which is also a vector. So don't forget about direction for velocity as well. Okay, so you just take that 156 divided by the 220. This should work out. Or 2, yes, 2. And then, what do we have, 6 and 7? I like 6. Did someone just ask me to do it? I'm going to let you do it. It's the exact same thing, but they don't give you the time, right? Okay, so let's draw it in for you. A train travels due east, oh my gosh, towards Toronto, for a distance of 120 kilometers at a speed of 100 kilometers per hour. So right there, what can you do there, Calter? If you have D and V, you solve for? Yeah. So go ahead and T will equal, what is it? D over V? Yeah, D over V. And that'll be T1. T1, D1, V1. So get the T from that vector. Then what does he do? North or south? South? South, a little bit farther, 230. So this is D2, 230 at a speed of 120. Okay, so do another calculation for T2. It's going to be D2 over V2. So you have 2 times. You're going to be able to add up those 2 times for the total time. So time total will be T1 plus T2. So the displacement question is quite easy. Do you agree? You just do the Pythagorean theorem, yeah? And then the inverse tangent, yeah? And then when you go to do the velocity, V average, you're going to use that displacement vector from A, but you're going to use time total in the bottom that you calculated. Okay, and then 7's quite easy. 7 is going to be identical, but you're just going to use velocity vectors instead of displacement vectors. Okay, so I'm going to give you time for 6 and 7, okay? Yep, right now. And then you can put, guys, you can put a line after 7 like this because after this is a second unit. This is all unit 2 business. Okay? You can see dynamics. So I'll give you time for 6 and 7, and then that should give you like 10 minutes left in class, and I'll let you have that time to yourself as well. But you stay seated, and maybe you work on previous homeworks. Okay? And you don't talk. Thank you. Unless you got a question, and you can get it sorted out. But be quiet, please.